All right, so this is going to be a video about Module 4, Lesson 5. We're going to talk about these things called proportions today. And a proportion is an equation like this where we have a fraction that's equal to another fraction. And we'll see some examples a little later of some application problems that can give us proportions. But in general, if we can get a proportion, these are pretty darn easy to solve because there's these things called cross products that we can form from these proportions that give us very, very manageable equations to work with. And in general, they're going to just get rid of the fractions right away. So it's not too bad. So if we look at a problem like this, n over 30 equals 2 over 5, we want to solve this proportion, then we are going to use the cross product. So what are the cross products? Well, they're products that we get when we multiply across the diagonals of our proportion. Okay, so if I do that first cross product, 5 times n is 5n. And the nice thing about these is the cross products are always equal to each other when we're working with a proportion. So 5n is my first cross product. 30 times 2 is 60. It's my second cross product, and those cross products are equal to each other. You'll notice now, no more fractions, right? Pretty darn easy to get rid of those fractions here. And then we just solve for n. So we divide on both sides here. So n has to be 12. So we can, if we have a proportion, we can quickly use the cross products, set those equal to each other, get an equation with no more fractions that's pretty easy to solve for the most part. Okay, our proportions will not always be as simple as that last one was. Might have a little more going on in them like this example does, but the strategy doesn't change. We're still going to find the cross products. We're still going to set those cross products equal to each other. So again, I'm just multiplying across the diagonals here. Okay, so the first one, 3 times 5 minus x. When we're multiplying something like this, 5 minus x that has multiple terms, we do need to put that in parentheses when we're setting this up. And again, I'm going to set that equal to what I get when I multiply across the other diagonal. Okay, but once again, this cross product strategy is going to very quickly get rid of all the fractions in our problem, give us something that we can solve. So our next step here is going to be to distribute. We'll distribute across the parentheses over here. Distribute the 8 across the parentheses over here on this other side. And once again, now we wind up with a linear equation that we can solve without too much trouble. So I'm just going to start collecting my like terms on each side. Move this 48 over. Okay, and then I'll move this 3x over. Basically, I'm just trying to collect my x terms on one side, my constant terms on the other side, right? It doesn't really matter which side you go with, but we just want to get our like terms together. So over here on the left, we wind up with minus 33. On the right, 8x and 3x makes 11x. And then we divide, and we've got it. Okay, so once again, these equations are not bad to solve if you remember the cross multiplying strategy here. We get those cross products, we set them equal to each other, get rid of our fractions in the very first step, and then we work from there. Okay, so we can certainly use this cross multiplying strategy to solve proportions for application problems as well. An example is we've got a situation where a scientist is working in a forest. He catches 180 deer and puts tags on them. So we've got 180 tagged deer in a forest somewhere, but we don't know how many total deer are in that forest. Okay, so I'm just going to call that X for now. Later on, that same scientist comes back and he catches 60 deer, okay, and he finds out that 18 of those deer have tags on them. Okay, so 18 out of the 60 total deer in that sample have tags. We are going to try to use this information to estimate how many deer are in the forest. So this is a pretty common thing we do with proportions, is if we have some of the information, we can use a proportion to estimate them. Okay, and so what I'm going to do here is set up a proportion for this. And there's several proportions that will work from this. The key is consistency in my setup. So I'm going to just set up a proportion by making first a fraction for this top set of data, and I can do it either way. I'm just going to say that X total deer goes on top, and then 180 tagged deer goes on the bottom. Now, you notice I did put the units here with these. You don't have to do that, but what it does do is it makes you likely to avoid the most common mistake that people make when they're working with proportions, because the key is consistency, right? You'll notice I put the total population was X. I put that on the top. When I go down, I'm going to set up a similar fraction for this second row of data, and I need to be consistent with my setup. I put the total number of deer for the whole forest on top. I need to put the total number of deer for my later sample down in the same spot. I need to be consistent with my setup here. I did total on top for the first fraction, need to do total on top for the second fraction. And that means I did 180 tagged deer on the bottom. I need to do the tagged deer on the bottom for this fraction as well. So again, the key is consistency. There are several other correct proportions that would work with this problem as long as you're consistent with your setup. Okay, and so once we get to this point, it's just a matter of using our cross products and setting them equal to each other. So going across this way, 18 times x is 18x. Going across this way, 180 times 60. We just multiply those in our calculator. Okay, and then we divide by 18, solve for x, and we've got it. And so that in your calculator. And so again, this is the number of total deer in the forest. Okay, at least an estimate. I probably shouldn't put an equal sign over here. Probably be more accurate to use the double squiggle to show that we're using an approximation, because that's what these proportions are used for. They're not used to give you an exact value. They're used to give you an estimate. So that's what we're getting here. Another kind of application problem that you'll see in this section is about similar shapes. In this case, we have two similar triangles. Okay? If we say that two shapes are similar, what that means is that the lengths of the sides of those triangles or whatever shape is similar are proportional. Okay? That means we can set up a proportion with the corresponding sides of our triangles and they'll be equal. Okay, so if I wanted to do that here, again, the key to setting up a proportion correctly is consistency. There's still several different proportions I can set up that will work here, but I do need to be consistent with how I set up. Like if I wanted to do a proportion where my first fraction just comes from the left triangle, I could certainly do that. I would just do 7 over 25. But I do need to make sure that I'm thinking about the fact that the top comes from the right side of our similar triangle and the bottom comes from the bottom of our similar triangle. So I need to do the same thing over here. Started with that 7 on the top of the first fraction. I need to start with the y on the top of the second fraction. 25 corresponds to that 15-foot side over there. Okay, all the angles are going to be the same in these similar triangles, so you need to make sure they're oriented the same way so you can match up the corresponding sides. And again, once we get to this point, it's just a matter of cross-multiplying, setting our cross products equal to each other. That should get rid of our fractions. So here, we're going to go across this way. 25 times y is 25y. Okay, go across the other way. 7 times 15. Divide. Okay, and this one does have kind of a very specific instruction at the end. It says to simplify your answer, type an integer, a fraction, or a mixed number. So we need to make sure we're following that instruction. In this one, we're going to wind up with a mixed number. We're going to divide maybe you haven't worked out with that in a while. So if we wanted to do that, we would take the top divided by the bottom. Goes in 4 times. 5 left over. And we can reduce that down to lowest terms. So 4 and 1/5 is going to be our answer here as a mixed number. This is question number 15 on your homework. So make sure you're paying attention to those instructions. We don't ask you for mixed numbers very often. It's a little unusual here, but if you want to get this one right, you will need to give it a mixed number solution. Okay, so hopefully that's enough to get you off to a good start. Not a bad lesson to finish things up on. And this is our final lesson for the course as far as the homework assignments go. So please don't hesitate to let me know if you have any questions at all. Let me know what I can do to help. Y'all have a good day.